The James Webb Space Telescope, JWST, has identified the following astonishing findings that may alter our understanding of the universe. Observed life. Could Proxima B actually be another Earth, or is it some kind of dangerous trap? The JWST, which is one of the most innovative tools we have, has recently been observing Proxima B. This planet orbits Proxima Centauri, a red dwarf star. Space enthusiasts and researchers have been intrigued by it ever since its discovery, and now, thanks to JWST, we are getting a better view. What we're seeing is pretty bizarre. We first heard about Proxima B in 2013, but only recently has the JWST been able to demonstrate what's really going on. The telescope can capture images using infrared light, allowing astronomers to penetrate the planet's atmosphere and observe details previously hidden. What they found is both exciting and a bit scary. Proxima B is extremely close to its star, only about 7.3 million kilometers away, which is less than 5% of the distance between Earth and the Sun. Because of this proximity, it only takes 11.2 Earth days to complete one orbit. But here's the crazy part: Proxima Centauri isn't like our Sun. It's a red dwarf, meaning it's unstable and frequently shoots out powerful solar flares. These flares cause havoc on nearby planets. This is where things get even more bizarre. JWST has now provided us with the clearest views of Proxima B. The planet is about 30% larger than Earth, giving it stronger gravity. But what's truly strange is the possibility that Proxima B is tidally locked with its star. This would mean that one side of the planet is always in daylight, while the other side is in permanent darkness. Imagine a world where the sun never sets on one side, and the other side is always night. That's not an ideal situation for life. The sun-facing side would be scorched by constant radiation, while the dark side would be a frozen wasteland. Could anything exist under those conditions? It doesn't seem likely, but you never know. However, the problems don't stop there. Proxima Centauri itself is a significant concern. JWST shows the star is much more active than we anticipated. Its robust magnetic fields create powerful solar flares that bombard Proxima B with vast amounts of energy. In one flare from 2021, the energy output was 100 times more powerful than anything we've seen from our Sun. These flares could strip the planet's atmosphere, leaving it exposed to the vacuum of space. Some scientists believe that because Proxima B is so close to its star and constantly hit by these flares, life as we know it cannot survive there. But others speculate that life might adapt to such extreme conditions. Could there be organisms on Proxima B that evolved to survive, or is it just a dead rock? As we continue studying Proxima B with the JWST, we're bound to uncover more. One thing is certain: this tiny planet, just 4.2 light-years away, is far more complex and puzzling than we ever imagined. Could Proxima B hold the key to understanding how life can exist elsewhere in the universe? If it does, what does that mean for our search beyond Earth? One of the most surprising things we've learned is that Proxima B might not even have an atmosphere. Radiation from Proxima Centauri and the planet's tight orbit suggest it's constantly bombarded by solar wind and high-energy particles that could have stripped away its atmosphere. But here's the cool part: some scientists believe there may still be a thin atmosphere composed of heavier gases like carbon dioxide or nitrogen. These gases might offer some protection against radiation. JWST has provided us with the best surface view of Proxima B so far, and it's both fascinating and puzzling. The planet appears to have a rocky surface similar to Earth, but with major differences. For example, the star-facing side is likely extremely hot, like a desert, while the dark side could be frozen with temperatures far colder than anything on Earth. But the most intriguing area is the twilight zone, the region between the day and night sides. This area might have lower temperatures, allowing liquid water to exist, which is one of the most essential ingredients for life as we know it. Could this twilight zone be a secret haven where life has managed to survive? Another surprise came when scientists considered the possibility of underground oceans, similar to those on moons like Europa or Enceladus in our solar system. These oceans might be heated by the planet's core or by tidal forces due to its orbit. If they exist, they'd be ideal places to look for hidden life. We also can't ignore the magnetic field of Proxima Centauri. Recent studies suggest its magnetic field could interfere with the planet's own magnetic field. If Proxima B has a magnetic field, it could potentially protect its atmosphere from solar wind, much like Earth's magnetic field protects us from the sun's radiation. However, the flares from Proxima Centauri may be so strong that they overwhelm the planet's defenses, leading to sudden climate and surface changes. These findings raise many questions. Does Proxima B have a magnetic field? How strong is it? How does it affect the planet's environment and its potential to support life? If life exists on Proxima B, it may be radically different from anything we've seen on Earth, or it might resemble life forms that thrive in Earth's harshest environments. Still, despite the excitement about a potentially habitable planet around Proxima Centauri, the truth is that it's a hostile place. JWST has revealed many challenges that life on Proxima B would face. One of the biggest is radiation. Proxima Centauri is not like our Sun. It's smaller, more chaotic, and constantly emits intense solar flares, including ultraviolet and X-ray radiation that would be deadly to Earth-like life. In April 2021, one such flare from Proxima Centauri could have wiped out any atmosphere Proxima B might have had. This shows just how dangerous red dwarf stars can be and makes us question whether Proxima B could ever be a safe haven for life. The James Webb Space Telescope has uncovered data that could flip our understanding of life in the universe. But is Proxima B really a new Earth, or just a cosmic trap? The JWST, perhaps the coolest tool we've ever built, is focused on Proxima B. With each new discovery, we move closer to answers that could reshape humanity's place in the cosmos. Despite the challenges, scientists are not giving up on Proxima B. In fact, the very conditions that seem so hostile might also be what make the planet worth studying. Extremes often provide the best laboratories for discovery. The intense radiation, drastic temperature differences, and potential tidal locking all force us to expand our understanding of what habitable really means. If life can exist on Proxima B, even in its twilight zone or beneath the surface in underground oceans, then it means life could be far more resilient and adaptable than we ever imagined. And if that's the case, then maybe life isn't as rare in the universe as we thought. New data from the JWST is expected to keep pouring in over the coming years. Spectral analysis might eventually confirm the presence of an atmosphere, or its absence. Temperature readings, chemical signatures, and magnetic behavior will help refine our models of Proxima B and similar exoplanets. We're on the edge of a new era in astronomy, where we're not just finding planets, we're studying them up close and in detail. But for now, Proxima B remains a mystery wrapped in contradiction. It is close, yet distant. Familiar, yet alien. Potentially habitable, yet incredibly hostile. Still, one question lingers above all others. If there is life out there, especially so close to us, what happens when we finally detect it? Will it change how we see ourselves? Will it shift our priorities as a species? Will we come together as a civilization to explore further, or will we let fear and uncertainty hold us back? One thing is certain, Proxima B is not just a scientific curiosity. It is a symbol of possibility, of how much more there is to learn, and of how small we are in the vast tapestry of the cosmos. The James Webb Space Telescope has shown us a glimpse of that future. Now, it's up to us to keep looking. As far as we are aware, it probably cannot exist on Proxima B. But others believe that life finds a way. Maybe creatures on Proxima B have gotten used to the wild conditions, or is the planet nothing more than a rock with no life at all? We're still looking. With the JWST focused on Proxima B, we can rest assured that we'll find more surprises. One thing's for sure, this little planet, only 4.2 light-years away, is way more complicated than we thought. We had no idea that Proxima B could be the key to understanding how life can exist in the universe, and if so, why? As a means of discovering alien life, we've learned some amazing things about Proxima B. One of the biggest surprises is that it might not even have an atmosphere, or at least not much of one. Because it's so close to Proxima Centauri, the planet gets hammered by solar wind and high-energy particles all the time. This constant attack could have worn away its atmosphere, leaving it bare and cold. But here's the cool part. Some scientists think Proxima B might still have a thin atmosphere, maybe made of heavier gases like carbon dioxide or nitrogen. This could give it some protection from the star's radiation. The JWST has given us the best look ever at the surface of Proxima B. It appears to be as rocky as Earth, but with significant distinctions. One side, facing Proxima Centauri, is probably baked by heat, so it's likely a desert. The dark side, on the other hand, could be a frozen wasteland, colder than anything on Earth. But the most exciting part is the strip between these two extremes, called the twilight zone. This area, where day meets night, might be warmer, with temperatures at which water could exist in liquid form. Since we know that liquid water is a key ingredient for life to form, this twilight zone may be a secret location where life has managed to hang on despite the rough conditions everywhere else. Another cool thing is the possibility that there is water below the surface of Proxima B. If water is present, it's probably in the form of ice on the dark side or small pools of liquid water in the twilight zone. But what really has people hooked is the idea of underground oceans, similar to those found on moons like Europa and Enceladus in our own solar system. These oceans could be warmed by the core of the planet or by tidal forces from Proxima B's orbit around its star. If these oceans exist, they would be great spots to look for life hiding under the ice. The James Webb Space Telescope continues its observations of this distant exoplanet, slowly unfolding the mysteries of Proxima B. Despite the fact that Proxima's conditions appear harsh and unlikely to support life as we currently know it, they also push the boundaries of what we consider possible in terms of habitability. This planet, orbiting the red dwarf star Proxima Centauri, holds key perspectives on the larger search for life beyond our solar system. One major question surrounding Proxima B is its potential for having liquid water, which is essential for life. While most of the planet's surface is either scorched or frozen, the twilight zone between the two extremes may provide a more temperate environment. This narrow strip of land, where day meets night, may have the right conditions for liquid water to exist, even though it would be constantly endangered by radiation and extreme weather patterns. However, scientists are intrigued by the possibility of underground water reserves, possibly in the form of vast, hidden oceans beneath the planet's icy surface. Such an environment may produce a secure haven for life, potentially even in microbial form, similar to what we see on Europa, one of Jupiter's moons. Another fascinating aspect of Proxima B is the potential contribution its core makes to its ability to support or safeguard life. Some experts speculate that Proxima B may have a magnetic field created by core activity. This could help protect the planet from the worst effects of solar winds and radiation. If true, this would be a game-changer in our understanding of what makes a planet habitable. Earth's own magnetic field protects us from solar winds and dangerous radiation. It's essential to sustaining life here. So, Proxima B's ability to generate a magnetic shield could make it more likely to support life. However, the strong magnetic fields of Proxima Centauri itself present an ongoing challenge. The star's unpredictable solar flares, which are significantly more powerful than those from our Sun, have the potential to strip away any atmosphere Proxima B may have, or at the very least, severely damage it. One of the most worrying observations is that during solar flares, high-energy beams could be hurled at Proxima B, including dangerous levels of ultraviolet radiation and X-rays, which would be deadly to most forms of life. Such conditions make the possibility of sustaining life over long periods appear slim, as any atmosphere would be vulnerable to being eroded by these massive bursts of energy. Moreover, the unique nature of Proxima B's orbit adds another layer of complexity to its habitability. The planet's rotation means that one side always faces the star, while the other remains in eternal darkness. This results in high temperature gradients, with one side potentially smothered in a sea of heat while the other might be a frigid wasteland. Life would have to find a way to survive in these polar extremes, or find refuge in a stable zone between them. But even in the twilight zone, the lack of shielding against solar flares would be a constant threat. Despite all these challenges, the JWST's discoveries continue to fuel the hope that Proxima B may be more than just a barren world without life. If there is life, it could be fundamentally different from anything we know, adapted to thrive under extreme conditions. Perhaps, in the deep ice-covered oceans, life has found a way to survive despite the odds. Or perhaps Proxima B will, in the distant future, reveal additional secrets that could alter our understanding of life's adaptability across the universe. The next steps in exploring this fascinating world could unlock some of the most groundbreaking discoveries in astrobiology and planetary science. But we can't forget about the problems. Proxima Centauri's magnetic field makes things even harder. Recent studies suggest that the star's magnetic field could interfere with the planet's core, possibly affecting its ability to create its own magnetic field. If the planet does generate a magnetic field, this could protect its atmosphere from being completely stripped away by solar wind, just like Earth's magnetic field protects us. Still, things around Proxima B are complex. The star's strong flares could overpower the planet's defenses, leading to big, fast changes in its weather and surface. All of this raises many questions. Does Proxima B have a magnetic field? How strong is it? And how does it affect the atmosphere and the potential for life? Could life on Proxima B have adapted to the wild conditions of the planet? And if life does exist, what would it look like? Would it be completely bizarre or novel? Might it be similar to the extremophiles that live in Earth's harshest environments? These extremophiles on Earth, organisms that thrive in boiling hydrothermal vents, freezing Antarctic lakes, or deep underground rock layers, prove that life can persist in conditions once thought impossible. If something similar exists on Proxima B, it would revolutionize our understanding of biology and how adaptable life truly is. The mere possibility has fueled intense speculation. Could microbial life be clinging to mineral-rich rocks in the twilight zone? Might tiny organisms live beneath the icy crust, feeding on chemical reactions generated by the planet's core? Or could life be something completely alien, not based on carbon or water as we know it? Even if we don't find life, Proxima B remains one of the best test cases for understanding exoplanetary climates, atmospheres, and magnetic dynamics. It's close enough for detailed observation, yet different enough to challenge everything we assume about habitability. Future missions, whether robotic probes, interstellar beacons, or advanced telescopes, will dive even deeper into Proxima B's secrets. With each new piece of data, we inch closer to answering the oldest question in the universe: are we alone? And perhaps, somewhere in the twilight shadows of a distant planet circling a dim red star, the answer is already waiting.